Alright guys, today we're going to do our last section with absolute value. So please find your sheet that looks like the one I have up on the screen. It has solving absolute value equations. We already did the graphing part with this, and we saved, if you notice there's blank spaces where it says algebraically. So take a minute here, dig out that sheet for me. It looks like what I have up on the screen for you. Alright, so the top piece of this, where it says solve the system by graphing, we're not going to worry about that piece because the graphing part we're finished with. We've solved graphically. Now it's time for us to move on to the solving algebraically piece. Before we can do that part though, before we get into some that are a little more involved, let's try to solve a simple one. And I don't have the simple one on your sheet, but let's try to solve a simple one. Up by the directions I put absolute value of x equals 2. I just want to solve that basic one. In order to solve it though, we need to go back to that definition of absolute value. Remember, absolute value is the distance a number is from 0. It's the distance a number is from 0. So if I have the absolute value of x equals 2, that means I need to figure out what numbers have an absolute value of 2. That's what I need to figure out. What numbers have an absolute value of 2? So in other words, what numbers are 2 away from 0? We've got a couple different ones. Well, the number 2 is 2 away from 0. Are there any other numbers, though, that the distance away from 0 is 2? Negative 2. Yeah, negative 2 is also 2 away from 0. So to answer this basic equation up here, the absolute value of x equals 2, we have two options. My x could be positive 2, but my x could also be negative 2. So the solutions to this basic one, I ran out of space there, could be x equals 2, could also be x equals negative 2. So two different values work out for x. Two different numbers have the same absolute value. It's the same number, but it's opposite signs. Now it shouldn't surprise us that we get two different solutions because we spent the last few classes solving graphically, and when we solved graphically, we got two different solutions. Like in example 1, we got x equals negative 5, x equals 1. We got two different solutions. We look on our graph, we had two different intersection points, which led us to two different solutions. Now I know a lot of you out there are really good with the graphing piece, like Miss Golly, why do we have to mess around with the algebraic part? Because it's not always convenient to graph. Sometimes we have to solve equations and there's not a graph for us to use, or the numbers just don't really lend themselves to graphing. Sometimes the answers don't work out as perfect as negative 5 and 1. So let's take a little look at number 1. I have the absolute value, but in this case I have an x plus 2, so it's a little more than just an x. But I have an absolute value equal to 3. So that means this piece inside of there, the absolute value part, it could equal positive 3, and we're in good shape because 3 is 3 away from 0. But that absolute value part could also equal negative 3. Oops, that's not a very good spacing there. Sorry guys, it is a negative 3. It's not letting me erase for some reason. So the absolute value part, that piece inside the bars, it could equal positive 3, and we're in good shape. But it could also equal negative 3. Now I have to go through and actually solve. So to get x by itself, now we go back to some of those solving basics that we started the year with and probably came in this year with. Subtract 2 from both sides. I get x equals 1. Subtract 2 from both sides. I get x equals negative 5. And I know some of you are thinking, Miss Golly, but we already got that when we graphed. And you're right, they should match. That's why I put the graphing and the solving algebraically on the same sheet. So you could see that it doesn't matter which way we solve, we get the same solution. I want you to be able to solve both ways because it's not always convenient to graph. Now you might be thinking, oh, Miss Golly, when we solved graphically, we could check our answers. Can we do that the same this way? Yep, the checking, guys, it works the exact same. And we already checked. We substituted, we put 1 in for x, and we also put negative 5 in for x. We already checked. If you feel like the checking part is something you need a little more help with, please feel free to ask me today. You're going to get some time to practice today. So if you need some help checking those, I know a lot of you on your quizzes did check when we did the graphing. You checked the same way we did when we graphed. You probably don't have any space left on your sheet to check, but you check the same exact way. Let's take a look at example number 2. Now example number 2, I don't have absolute value bars all by themselves. I don't have that. So before I can start thinking about negatives and positives and what could the absolute value be, I need to get this absolute value all by itself first. I need to get the absolute value all by itself first. So how do I move that plus 2 out of the way? How do I get that plus 2 to the other side? Minus 2, yeah. So let's subtract the 2. Subtract the 2. And we have 2 equals the absolute value of x. Yeah. Now, once the absolute value is all by itself, now I can start thinking about the positive case and the negative case. Now I can think about those things. So the absolute value is all by itself, which means whatever's inside of those bars could equal positive 2. Whoops. It's not letting me erase, guys, sorry. There we go. Could equal positive 2, or what's inside of those bars could equal negative 2, and we're in good shape. Once you get the absolute value bars by itself, then you have to start thinking about what's the positive number that we could equal, and what's the negative number that we could equal and be okay. Because the absolute value of 2 is 2. The absolute value of negative 2 is also 2. And if you notice, we once again, we match what we got when we graphed. How do you check? You check the same way, and actually it looks like we probably have a little more space on this one. So let's go ahead and check. I just want to show you, you do things the same way, and maybe some of us might need that extra little check as well. So when we check, let's start with x equals 2. We have 4 equals the absolute value of x. So instead of x, we're going to put a 2, and then we have a plus 2 on the end. Absolute value of 2 is 2. Remember, I don't change the sign. It's how far I am from 0. And 2 is just 2 away from 0. So we end up with 2 plus 2. We end up with 4 equals 4. Now, I often get this question when we start solving algebraically, do I need both of those answers? Yeah, we do. I know it's a lot easier to see when we graph, because when we graph, we have that V shape, we have 2 intersection points, it's easy to see we have 2 solutions. But now we need to take what we know visually would happen with the graph, based on all our practice, and we got to apply it to the algebraic piece where we don't have that graph, we don't have that visual piece of, I see there's 2 intersection points. So we check the other one, x equals -2. So we've got 4 equals absolute value of -2 plus 2. Absolute value of -2, we are 2 away from 0. And then we get another 2 plus 2 equals 4. Do I need both solutions? Yes. So when we go to solve an absolute value equation, you might not always get to graph it, but we've graphed so many though that hopefully that visual, that reminder of, hey, it's the V shape, hey, we had 2 intersection points, hopefully that comes to mind when we solve these algebraically. So a couple big ideas off of these basic ones. Once I have the absolute value bars by themselves, my absolute value could equal the expression inside the absolute value bars could equal a positive. The expression inside the bars could also equal a negative of that same number, and we're okay on those. So if you go to the back side of your sheet, let's continue on with these. And again, I put it with the graphing sheet so we can first of all see that, hey, both of these ways work. But second of all, so we can remind ourselves and have that visual that there's 2 solutions, there's 2 intersection points. Now, the algebraic piece, I need to get, before I can do the positive negative case, I need to get the absolute value bars by themselves before I can worry about a positive case, negative case. So right now I have a 2 in front of those bars. How do I get that 2 out of there? The 2 is right next to the bars, so the 2 means we multiply. So how do we undo multiplying? What do we think? How do we undo multiplying? Or what's the opposite of multiplying? Yeah, we divide. Yeah, we divide. So we're going to divide both sides by 2. So we have the absolute value of x equals negative. You can leave it 3 over 2. I know a lot of you would pop that in your calculator and you'd get a decimal of -1.5, and that's fine. But now here's the problem. Here's the problem. Absolute value always comes out to be positive. Absolute value is a distance. No matter how hard I try, there's not a value I can substitute in for x and end up with -1.5. I mean, I can try to put in 1.5, but the absolute value of 1.5 is 1.5. It's not going to equal a negative. I can try to put in -1.5. But the absolute value of -1.5, again, is 1.5. No matter how hard I try, no matter what value I put in there for x, absolute value of any number is going to be positive. It's the distance we are from 0. It's going to be positive. So this one, this is a no solution. This is a no solution. If you want the y behind it, it's what I just talked about. Absolute value cannot be negative. I know for some of you it makes you nervous when you have to put a no solution down. You're like, oh, but how do I know I'm right? I can't really check that. Well, I did kind of check it already though. This piece up in here, I tried putting in different values for x. I tried +1.5, I tried -1.5, and well, they didn't work. You don't have to show me that work. If you have an absolute value equal to a negative, you can just put no solution. If you want to put the little explanation there, you sure can. And this one, it is backed up by a graph. It is backed up by our graph. And I know when you guys take your quiz tomorrow, I'm not going to have the graph on there. It's going to be just algebraic. So you're going to need to make sure you're checking your answers and not just, oh yeah, it matches what I graphed. This one does match. We've got it backed up with the graph with the no solution on this one. Sticking with that same idea, in number 4, I need to get those absolute value bars by themselves first. I need to get them by themselves first, so I've got to clear everything else out. I have a negative 1/2 right in front of the bars, which means we're multiplying. I cannot distribute. I cannot take that negative 1/2 and put it inside the bars. So I have to undo that multiplication. And we did a lot of solving with fractions. Don't let the fractions throw you off. Most of you out there use one of my calculators that has that nice little ABC fraction key on it. So if you need to do negative 2 divided by, you need to use the calculator to divide by negative 1/2, I'm not going to stop you. Don't let the fractions scare you away from this kind of problem. After I divide, I'm left with absolute value. I do my division. A negative divided by a negative, here's where we have to be really careful on these. A negative divided by a negative gives me a positive, and it does end up being positive 4. We really have to be careful when we do some of our computation on these, because if I forget a negative sign and I end up with negative 4, I'm going to end up putting no solution instead of what that actually should be. So now I have the absolute value all by itself. So the piece inside, which is just an x, could be the positive case of positive 4. What's inside those absolute value bars could also be the negative of that same number. Absolute value of 4 is 4. Absolute value of negative 4 is also 4. And again, you will have some time today to practice. On your practice work, you'll have space to check. On your quiz tomorrow, you'll have plenty of time. So if you want to check, I encourage you to check on there. So the first few, we just really had one step and we could get the absolute value bars by themselves. Think about the positive case, think about the negative case. Now when we move on to number 5, we're getting a little bit more involved. A little bit more involved with number 5. What we need to think about, I've got to get the absolute value bars by themselves first. Don't go right into, I need 2 different cases, I need 2 solutions. We've got to get the absolute value bars by themselves first. I like to circle what I'm going to try to get by itself. If it helps you, let me make a little suggestion here. If you need to, you could write it without the absolute value bars, just to visually see, hey, how would I get that x by itself? The steps to actually get the absolute value bars all by themselves, guys, it's the same steps we've been doing since the beginning of the year that you guys did last year and probably the year before. But you've just probably never done it with absolute value. So if I look at it more basic without those absolute value bars, we know we need to undo that subtraction first by doing addition. We know that. So we end up with negative 2. We have 2 times the absolute value of x. And I know some are like, wait, Miss Golly, it's that negative, and I see from the graph it's a no solution. You need to make sure you see it all the way through, though. Get the absolute value bars all the way by themselves before you make the decision of if it's a no solution or not. Last but not least, I still have a 2 in front of those absolute value bars. To undo the multiplication, I have to use division. Negative 2 divided by 2, I get negative 1. And now that the absolute value bars are all alone, now I can make the determination, hey, absolute value cannot equal a negative. Absolute value cannot be negative. So that means our final answer is a no solution. Don't just look at this one and say, oh, it equals a negative and write no solution. You're going to have a negative on this side of the equal sign quite a bit. So you have to make sure you follow the process, get the absolute value bars by themselves first before you can determine, hey, this is a no solution, or hey, it does have solutions. Make sure you get them all by themselves first. Okay? All right, and our last one, I beefed it up just a little bit. We need to get the absolute value bars by themselves first. You guys all know how to solve an equation for a variable. Now you're solving it to try to get the absolute value bars by themselves. So this is the piece. If you want to circle it, you can, doesn't matter. That's the piece I want to get by itself before I can do anything else. To get the absolute value bars by themselves, those steps aren't new to us. Those aren't new at all. We want to start with undoing our addition. To undo addition, we subtract. -5 minus 3 is -8. And again, I would make sure, if you're feeling shaky with the computation part, have your calculator there just to double check that. I know everybody in this room can do -5 minus 3. I do not doubt you one bit. But I know we get in a hurry sometimes, and all of a sudden -5 minus 3, we're writing a 2 there, or a -2, or a +8. It happens, I know. So just take your time on these. Last but not least, I know that -2, it's sitting in front of those bars. I know it's really, really tempting to distribute that, but we can't. Absolute value bars are not parentheses. So to undo, that's multiplication, since it's right next to those bars. To undo multiplication, we divide. So absolute value is still there. I have not found the absolute value yet. All I've done is gotten it by itself so I can solve. That's all I've done. The process to get it there, it's the same steps you guys have been using all this year, probably last year, and for some of you even the year before. Now, once you get the absolute value all by itself, then that's where it's a newer idea for us. Absolute value, there's two different numbers that have the same absolute value. For this particular one, we're interested in the number 4. So I take what's inside of the bars. I take exactly what's inside of the bars. If that equals +4, we're in good shape. If what's inside of the bars equals -4, we're also in good shape. 4 and -4 have the same absolute value. Now, it shouldn't be a big stretch for us to have two solutions because we've been graphing these the last week or so. We've seen two solutions. We can see it on our graph right now for number 6. How do I finish off solving these? Well, to undo the subtraction, we add 1 to both sides. X equals 5. Add 1 to both sides on our negative case, and x equals -3. So your first thing you want to recognize is that when you have absolute value bars in your equation and you want to solve, you're going to get two solutions. There's the potential of a no solution, absolutely. But our typical case, we're going to have two solutions. Once you see the absolute value bars, in order to solve, get those bars all by themselves. So do any adding or subtracting, do any multiplying, dividing you need to do. Once you have the bars by themselves, you need your positive case, you need your negative case. Solve each one. Make sure you check. If you notice, we have the same solutions as our graph. And we already had all of that check work there. If that's something you didn't do the first time through, I'm going to leave my screen up here for you. I would take a couple minutes and I would go through that check work. You're going to have the rest of the time today to practice. You've got a big chunk of time left to practice. Make sure not only I'll have my answer key out, but make sure you're not only using my answer key or the ones you've already graphed, but make sure you're going through that checking process. So when you take your quiz, you can check every single one of your answers and make sure you're right before you even turn it into me. Okay? So you have the rest of the time today, you have a packet that looks a lot like this sheet. You already did the graphing on there. There's 12 problems. You already did the graphing on there. So now your objective today is to finish off with that algebraically piece.